The first presentation will be delivered by Sber team. We will begin with Vladimir Kravcev, the leader of computer vision team. Then A.Belikov, head of the area in Sber, will continue. Then T.Voronova, also head of an area, will continue. The only lady today. The presentation would be video analytics for monitoring security in public areas, from requirements collection to realization. And I would like to tell everyone who watches us that there should be a QR code on the screen. If you use your smartphone, it will be possible to ask questions. If questions are correct, ethical, and interesting, we will ask them. But there is a condition that speakers should make it on time, because timing is different. Vladimir, over to you, please. Thank you. Thank you. Hello, everyone. My name is Vladimir Kravcev. I work in the Sber team, focused on computer vision. Then, together with Alexei and Tatiana, we will tell you about one extraordinary and complex project we implemented in Sber, and we were inspired for 1 year. The contents, I would not like to repeat it, so I will begin with the goal set. Then Alexei will talk about the devices, and Tatiana will talk about models and their optimizations. So the general task was to do the processing of video online from 5 to 6 cameras, a standard project for computer vision. But all cameras was specific, that all cameras were on vehicles, cars. Our session is not dedicated to business, but rather to technologies. I'm not able to talk about the business side, but let's imagine that it's a police. You, as a minivan. When we began the project, we realized that there would be a problem with data processing and transfer, because the maximum we have is 4G channel, and the car is in movement, so some problems with connections are inevitable, and the modules should be installed inside the vehicle, and it led to a number of restrictions with the device. And the insight, an exciting insight was that when we started to get data from a real vehicle, we understood the problem with the light changing day and night, and there were all problems with weather, sun and rain and mud, and we realized that we had to do with the marking, but having an edge device on board gives a number of advantages. You don't have to synchronize video streams. We don't waste resource on sending data to the center, and if we want to share, there are online notifications on some events for the employee who is in the vehicle, and the computation module allows us to get connection with other devices on the car with the control system. As for the task setting, we had to develop hardware and software part, and there are limitations on the side of the bank related to security, cybersecurity. I will skip details, but some interesting insights resulting from the project. The number of models grew when we worked on the project. We began with 6 to 8 models. Now there are rather 10 to 12 models. And it's good that at the early stage of the project we changed our approach to modeling. We have new models, and we didn't have to do the learning of older models. And our conclusion was that if the project is new, some changes are inevitable, but you can get prepared if you do the modeling process the way the changes are possible later on. The second conclusion. So the device was quite costly. We installed it at first, and the customer wasn't happy with the price, but we started prototyping, and during the project we boosted our competences in adapting the models, and we reduced the cost of the final equipment nearly 2 times. And STK, a sister company of Sberbank, helped us, and we realized that we need to produce our own device, and STK company helped us. And the outcome, the conclusion was that it was correct, that we shouldn't have looked for a ready solution, but we started with an expensive solution to optimize the model, to do the prototyping, and that led us to a success. So, then next I would like to hand it over to Alexei. Alexei will tell us about the models. Hello, Vladimir. As Vladimir, you said, to put an edge on a board of a vehicle, like a portable computer device with some extra computers. That was our goal. The difficult side was that a vehicle has limitations on power supply and vibrations as it moves, offers more complications. So we shortlisted a number of criteria to select the device. First of all, research the product. Time from you start your research of the device till all pipelines of neural networks is introduced. Also, the limitation on power was important. Those limitations don't allow the devices to use their full computing resources, being connected to other sensors. Also the computing resource. The installing more chips that would enhance the speed of computations. But the most important thing was the ability to receive up to 5 video streams and make them going through neural nets pipeline in real time. And we noticed that every device is special and have a number of features. The first feature is custom firmware, because every device has its layout of peripherals. What has to do with the power or extra peripherals. And we had to implement different firmware for every device. We took a unit of equipment from one manufacturer and try to do the firmware, and we couldn't do it on time because they were celebrating Chinese New Year, and our timing was delayed. Also, Edge is first of all hardware, not just software. If it fails to work, it doesn't mean the problem is about software. You need to look the problems comprehensively. If video stream is stopped, it may be the problem with the corrector or the cable connected to the camera. And another specific factor was whether computation were possible in case there is a surge in power consumption. Not all resources can be used, not all kernels that can be used for parallel computations. When we started prototyping, every data scientist selects the device he likes. So our team loves PyTorch, and PyTorch allows to select the neural nets quickly. But when it's about optimizing neural nets, there are some issues. They can be resolved, but the time for testing and research this or that device grows. So that's why proprietary devices are preferable. Like for Jetson, it was easier to take a ready model from the box and then test it on how it can be used. And for JStreamer, you can merge a number of streams, make them go through a number of neural nets. But again, it can be optimized not just in terms of quantumization, but you can optimize it in case of Jetson for different devices. As for optimizing and the methods we used, so Tatiana will tell you about this. Tatiana, over to you. Thank you, Alexei. Requirements for the hardware translate into requirements to the models. So we used learnings to make life for the model easier. So we used crooning of classifiers, and there were three models selected: SNet 18, MobileNet 2, MobileNet version 3 was not part of our experiment because we didn't have any layers that would support it by pruning mechanism. There are a number of strategies on how you just clean, sparsify the model. You can learn the model which is already stratified. You start with it, and then you remove some weights, and some go up. And there is iterative, like pruning. You do it step by step. A number of steps, which you do following a schedule. So it's first you prune it, and you train a number of steps, then you repeat it, remove the number of weights, do the additional training, and you track the accuracy of model and the speed, and you assess how light the model became. So here at the slide on the right, you see how it was used. And we had a number of options with iteration repeating a number of time with subsequent fine-tuning. Here you see measurements for one of the classifiers. As the speed of a model is a key parameter, finally we selected S18 net for classifying, and after the 9th pruning iteration, the speed difference becomes obvious for different patch numbers. So, and as for the inference model, we found the end model, but the final time made 0.4 milliseconds for 2500 FPS for the batch size of 16. And for the detector, we used the proprietary model. And after the pruning, we got 200 FPS. I think I'm done with that. Now over to Vladimir with the conclusion. Something went wrong. Thank you, Tatiana. The project proved to be quite difficult, but we were really happy because we were involved from the very idea, the conception, till the delivery. Some elements of the project were sent to the patent agency, and we expect their decision till the end of the year. So, interestingly, we tested hardware from NVIDIA for a number of 4 years, and it proved to be very efficient in cold and hot weather, no failures, no problems, and we can recommend it. Dear colleagues, I hope that we managed to show you that the computer vision technologies are quite mature. They are no longer used inside only, but in the field as well. I would like to thank everyone who took part in our project, especially STK company, and very quickly, being pressed for time, we managed to find this solution, and which was acceptable for everyone. I am done. Your questions, please. Thank you, guys. I realize that topic, it's close to me, transport, telematics. With your permission, I'd like to ask you the question.
So now I can see that you have this approach and you have applied for a patent, but can you kind of popularize your product? What stage is it at now, and when will it be on commercial rails, so to say? Because I know that Sber does a lot, not only for itself, but also issues it into the external world as a product of an ecosystem. Yes, thank you very much for your question. I will now explain that we are now following the last mile, I would say, going through the bureaucratical procedures of the bank to receive promo, tick, and around 10 machines have been tested on that. But before we give it to the external market, we have to test it on ourselves so that there is the Sberbank quality mark, and we will be really proud of that. So I believe it is preliminary to say, to speak about the release to the external world, but I believe that next year it might happen. So do you mean to say that in 2022, a comprehensive solution for this kind of transport vehicles outfitting will go to the market. Well, yes, but we have to understand that we have given an example of police car, but it can be a crane or something else. So where the capacity, the power is enough, then it will work. Thank you. And then I have a practical kind of question to the developers of this story. You have gone along a really long path, and I know several teams that are working on transport telematics so that information from vehicles can be processed on board. So what would you advise these people not to do? So you have shared with us what to do, but what not to do, what to avoid. Actually, in our presentation, we tried to a little bit highlight these moments of what to avoid. Well, can you sum it up, please? I'm afraid I am not ready to do it right away because I am now more focused on our success than on failures. Okay, if you don't have an answer right away, it's okay. So the more important thing to have a wish, and then the products will appear. So Vladimir, Alexei, Tatiana, thank you very much. It is really very interesting, and what is important is that what you have done is of applied character. Thank you very much.